Hey everyone in DevOps land today. This is Micki Boland. I'm so glad to be here with you for the DevOps Summit Canada for 2024. And I'd like to thank you for joining my session. And I want to thank Garima and all the people who put this on. And also Garima and your colleagues, the amazing work you guys have been doing in developer operations, but also developer security and velocity in development. So very, very glad to be part of it, and I thank you again for all you do. For you guys, I hope this will be entertaining a little bit and maybe a little bit fun. I might show a Christmas puppy, so stay stay connected, and we'll get into some things about web application firewall and API security, but a little bit about securing you guys as developers, your endpoints that you're using, the platforms and tools that you use as well, and then a bit on how you can automate security in your development cycle, and we'll talk briefly about that. So, my name is Micki Boland. If my slide will advance, I am a global technologist at Checkpoint Software Technologies Office of the CTO. What does that mean? It's just a big title that means I get to go and have a lot of fun talking to you guys, working with teams, studying emerging tech, reconnaissance of emerging tech, and then really working with emerging tech and how we can actually have a cybersecurity intersection with emerging tech. How can we adopt it without incurring additional risk? How can we have velocity, be agile, and mainly have the competitive advantage on whatever we're working on for our organizations? Even if it's a government agency, it can be outsourced or it can be insourced, or you guys can do it. The more efficient and more agile, the more excellent that you guys are all developing and managing development teams and managing software factories, the better. So we'll talk about that briefly, and we'll get into some very specific stuff. And then if we have time, I'll show you around shift left security, which is like software SCA. So we'll look at running something in your IDE so you can see if there's anything embedded secrets or malicious URLs, or anything embedded in your code, vulnerabilities, dependencies, and we can do a little bit of SAST and DAST and show you how that looks in the platform if there's time. So please link in with me if you will. My LinkedIn is here. And also, if you want to learn more about Checkpoint's developer security platform, it's there. This is not a sales pitch, nor is this a product pitch, nor is this a solution or platform pitch. I'm talking to you strategically and also sharing a lot of information about what what I'm learning from talking with customers and what you guys can maybe take from that and glean it and use it for your own. So first of all, I gotta say, like, what's in it for you? What is in it for you to listen to me today? What is it in for you? What is in it for you to add security in the development cycle, no matter what part of the cycle you're involved in? If you're coding or you're a software engineering leader, or if you are a DevOps manager, or software engineering, we'll talk about these things. Why do you want to listen to me? Is because I understand that you guys are all about velocity and freedom and autonomy. So, like, you really don't want people getting in your way. You guys need that creative freedom. You need to be agile though, because the organizations are pushing you guys harder and harder to deliver enhanced software updates, software packages, and new software to your own customers. So it's important that you know that I'm here to help you guys. I will be a champion for you, and a lot of what I talk about will hopefully help you guys in your jobs. The other thing I want to leave you guys with really quick is with generative AI, we actually seeing quite a lot of coding or code assisting in the platforms themselves. And this is really awesome. But we're seeing also this inflection point of low code, no code. So more infrastructure as code, development on the fly, There's a composable network, there's composable applications, and there's even composable enterprise, where the enterprise is kind of like Inception. You can like think of it, there's like multiple layers of building out stuff and killing it. So keep that in mind as companies become more virtual. The development is more virtual. They're getting towards more composable architectures. So infrastructure as code, code on demand, building applications on demand, killing them when they're no longer needed. You guys start thinking of these principles. That sounds like a lot of bit of forward thinking, but it's coming very quickly, you guys. And I want you guys to be involved in strategic and tactics in what you're doing, and that you have value always in what you do, but also by taking on specializations for enhancing the whole development cycle, for adding security in. You guys are doing something really huge for your company, and you're actually going to be even more valuable to add this to your skills. We'll talk a little bit about web API security, and we're going to talk about how the WAF that we have works a little bit under the hood for code, the architecture and the code that's available, components, and then we'll go into the playground. Um, I think it's super important that you guys understand technical debt is driving a lot of excellence in development, and the idea is that NIST put out a report. This is like 2 or 3 years old now, that said if you fix a software vulnerability or a bug, or some type of security issue, dependency issue, or just an out, software excellence. If you do that early in development, it may, like, let's say it's 8 hours to fix that. If you wait until it's in production, it's going to be 15x. 5 times, 15 times the amount of time to fix that bug or that software glitch or um, vulnerability or dependency when this thing is up, your application is up and running in production and serving customers. So keep that in mind. The other thing is, I hear security people say, well, developers don't really care about security. And I say that is not true, because every development team that I talk to is very interested in security. All they want is the business to give them the guardrails, the tools to actually be able to use it. And you can't have a bunch of false positives. You can't have security people telling you fix 10,000 million vulnerabilities, dependencies, and you don't know where to start. And you can't have, like, people overlording you and slowing down your sprints because you have things that you have to deliver to the business. So it's a balance. But what I'm saying is every development team, engineering leader for software engineering, software dev teams, leadership, cloud platform teams, developers themselves, maybe at the lowest level of coding, a very specific part, um, even are caring about security. No one wants to be that guy that was on the team that released an insecure uh, solution, right, or application. So, or a security patch or something that opened another door. So fix one bug and open another. The other thing is all of this can be done for you so that you have efficiency gains, not to slow down, because people think cybersecurity teams, infosec teams, the CISO org, that they don't care about your ability to get the software done in the time that the business is asking. They, you think that they're going to tell you no or throw a bunch of stuff at you that you don't know how to fix. I'm telling you right now, all this can be automated. You can actually have a security child pipeline that actually runs when you run an action in GitHub or GitLab, that actually plumbs in all the tools, assesses it, and gives that feedback back to you. You can even put it into a portal so that you can show the business, hey, here are the things that we found, here are the things that we fixed. We can run this in the IDE. which is the perfect place. I have infrastructure as code. I'm deploying this application on in Google Cloud Platform, and they have too many ports and services open. I have malicious code potentially. I have embedded secrets. I have dependencies and vulnerabilities for open source code that I'm using. I can fix all that in the IDE. So that's the place to do it. But ultimately, we have to be able to tell the business that we're reducing technical debt for the business, we're reducing risk for the business, and that we're actually providing the business visibility. And visibility is here's what we did, here's how we fixed it, here's how we reduce the risk. And if you can't show that with an enterprise class platform, you can use a lot of plugins, but it's not going to give you what you need for the business. Ultimately, you guys are the secret weapon because you build security in the software dev cycle and in the runtime or production application. You guys, it's so immensely important and valuable to the company what you're doing, and you can show that. So what we want to do is not let you guys think that all this stuff is going to cause all kinds of challenges for you guys and things you have to do and cause you pain. So ultimately, it's going to actually reduce pain for you guys, give you more velocity, efficiently add this stuff in, give it to the security people the results that they need, give you actionable things that you can fix. There's embedded key, there's excessive permissions, there's a vulnerability in this runtime. We can give that to you and show you exactly where it is in the code and how to fix it, and then you can have your a lovely life and the happy path, right? So I just want to bring those things to you and let you know I'm a champion for you. All right, so let's get into it. So, what are some web and API best best practices? I'm going to talk a little bit about generative AI and large language models. But for web, been a long time around the OWASP top 10 risk for web applications. And also, OWASP has a top 10 for API risks. These are very good things that show you where the biggest risks are inherent in web services, web applications, and API applications using APIs. So I want you to always look at that and talk to your security teams. I've seen teams, now I'm working with teams where they've hired cyber people that are developers also into the team. And then I've seen where the developer team has actually sent a person over to the cybersecurity team to help them securely automate building security in. So we will talk more about that. But if you want, always look to OWASP. If you're not familiar with these, I have the links. Go and check those out. This is the most basic and most important testing that you can do for web applications and applications using APIs because these are the common things that are exploited and vulnerable or can be targeted for exploitation. The other thing is OWASP has now a top 10 for large language models. It talks about data poisoning, large language model theft. That's intellectual property now, you guys. The data that's been prepared by data scientists for training and testing in machine learning and neural networks and deep learning, that costs a lot of money to prepare that data and to ensure that the algorithms are properly built. All of those become a target. And the model theft, the model itself. These are intellectual property things that adversaries want to steal from your company. So just like your data, the data integrity and the data privacy is key. Tokenization, you can use some redacting, you can use some stochastic masking to actually kind of obfuscate the data because most of the data that we're working with in these is production data. It's live data. So we'll talk more if there's plenty of time. We can do another session. I'd love if you guys, I can help you in any way. Just reach out. I've got people that I work with. I'm not the only person. There's a million people that we can bring in to work with you and help you actually build and create security for these. Okay, so documentation. Many times we see that application flow, and I'm talking about who's the consumer of the application, where are they? External or the internal? Are they a business to business? Is it a customer to business model? What is that? Where is the application being served? What is the application talking to? What communications does the application have? What API calls is it making? Where are these? Where's the endpoint for the API services? All of these things have to be documented in a business logic. They should be documented. We're pretty good at web apps and maybe mobile apps, what's going on there. But we find out on APIs where you actually are exposing APIs to your customers, or you're serving up an application that you develop or partially develop that's making API calls to various places, including cloud. A lot of times that logic is not well defined. Nobody knows what the endpoints are, where they're served out of, what versions are they running. So all of this has to be documented. And then the other thing is you need to be doing continuous monitoring on these things, because once it that basically, so you have APIs running, you're using open API specification, and you're using APIs to for your platform that you're serving up to your customers. Are you using the right APIs? Are you testing them? Many times, probably about 80% of the time, these are not being security assessed or tested in any way. And they're not documented. Like, there's no inventory a lot of times of all of the APIs that are exposed. So I'm going to ask you guys, I'm going to beg you guys, if you don't understand about this, or you do, share that knowledge with others. If you don't understand, let's get on the train, and I'm telling you, it'll deliver a lot of value for your organization and for you as a person. The other thing is data integrity, data privacy. At no point in time is data more important. Data is the holy grail. If it's encrypted, that's amazing, and the application is encrypted all the way through. A lot of times there are points where there's encryption is not really possible because we're using live data. Again, we can talk about techniques for obfuscating that data, but ultimately we want to make sure that, especially for our generative AI, that our machine learning and neural networks and deep learning, our algorithms are protected, and our data, our training and test data is protected. That data was prepared. It's super important. If we're just scraping data from like the internet or using a platform like OpenAI, we can't really, ensure that we're getting good data, and that has to be part of your model and what you're doing as an organization and how you're utilizing that data, because the data should inform the results of the deep learning. It should inform, but ultimately it shouldn't be making decisions for human beings. It can inform human beings to make decisions, but we have to understand what's under the hood and when we do that. Use open API specification, you guys, for your APIs. It's not a question of should we. It means you must use, and you should hear. It's not optional, and you should document. So again, best practices, documentation. If you have stuff that's running already, go out there and formulate a plan to get that stuff assessed, inventoried, and assessed. If it's already running and you came on the team and the stuff's already running, try to find out where all your APIs are exposed. It's super important. How are people getting to them? How the application's getting to them? Are they in a service fabric that's secure, like a API endpoint service that's running in like a private cloud environment? Or are you actually doing data dips via API calls out to like a public repo like Rapid API? These things are super important. Document, security assess in dev test, in UAT, pre-prod, and production. So when the application's in runtime. So also, if you're running APIs, if you're serving APIs up for your organization, rate limiting is one of the most important things you can do. Two things: schema validation, so enforce the API schema is correct when the communications are going on. And number two, ensure that you have rate limiting so that your APIs cannot be overrun by rogue applications or attacks. Also, you can do all of these things through automation and reduce your basically your overhead, and we can reduce false positives. So high degree of specificity, which means threats and potential problems are found, right? We have to find them 99.9999% of the time. We have to find them. But we also don't, on the inverse, we don't want to give you a bunch of false positives. That kills people, right? That makes people chase tails, and then they don't believe anything that they get or any actionable. There's nothing actionable when you have like gazillion false positives. So also ensuring that the efficacy is very high so that you don't have false positives, that you truly have positive results that require someone in your team to go and fix and remediate. Also, you can use AI based threat intelligence. That's another topic for another day, quite a lengthy day as well. Um, and you can actually, we hear about shift left, so they're saying push security all the way to the left, starting with your endpoint that you're using as developers, your identity and access management, the tools and platforms that you have access to should be at least permissions for you to do the job that you need and only the job. Maybe they're time sensitive. That you're onboarding and offboarding projects through your HR or ERP management is being done properly, so that like you don't leave a project and then have access to that project after, all the way through checking your source code, open source code, third party code libraries for dependencies, vulnerabilities, malicious URLs, malicious IPs, malicious code, all the way through the cloud platforms and services that you're using to dev test, to run in the cloud, metadata services. And now the application is developed completely and it's passed all the QA and it's in production runtime. The application is in use. Your customers are using it. We want to do the shift right. Now we want to shift right and put security in there. You can actually do that whole piece all the way through automation at the earliest stages in development cycle using automation, and all the way through that application now is running in production. The security is wrapped around it. It's doing continuous monitoring. It's logging, continuous monitoring, sending security events, telemetry, so known security events and active threats, contextual, real active threats based on AI threat intelligence, to a central monitoring place or cyber mesh where these things can be seen in real time. You can plumb that in as the developers for the application in runtime in production. We'll talk about that if you want to. Other than that, I will leave you with this. APIs are everything, so I'm on the warpath of API security this year. It's the most frequent attack vector. If we look at attack successful, highly targeted attacks, I'm going to name a few. I'm not calling these out. This is well known. T-Mobile, Coinbase, Venmo, Peloton, Experian, LinkedIn, which they make us all use, right? Instagram, Bumble. These were actually all attacks that were perpetrated against the APIs that those companies were hosting. So I want you guys to understand the severity and the importance of what you're doing in listening to this session and thinking about, what we can really do as a team and starting to get the sensation that security is good for you and it can be automated. It can let you do velocity that you want, have your freedom to operate, and also keep you out of the doghouse. But ultimately, what you're doing is reducing risk for the corporation, and the risk managers and the C suite love that. All right, so web and API benefits and features. This is just a quick screen capture of our WAF portal. I'm going to show you there's tons of ways to actually deploy our WAF agent. You don't change the architecture. It's super easy breezy. We have an open source version called OpenAppSec. It's available on openappsec.io. I'll show you that. And you can actually run this. We're going to show you a quick lab version of what it looks like to deploy it in the playground. You can fully manage these and use enterprise class threat intelligence. You can use the open source version right now in your lab, in your real environment. You can use CrowdSec. You can actually get security events. You can use CrowdSec bouncers rather. And you can also, if you like the telemetry, you can actually get checkpoints, AI based threat intelligence that does correlated security events against your environment in context. So we can talk about that. You got to have the OWASP top 10. You have to be able to reduce those risks. That's important to the business. Any tool worth its weight is going to be doing looking for the OWASP top 10 risks for web and API in large language models now. API security, can't stress it enough, you guys. It's not being done. You want to shield your applications from exploits. If you're using REST, GraphQL, you can actually do schema enforcement and then enforce that you're using open API specification. You can look at infrastructure as code, JSON YAML templates, Terraform service provider templates, and then you actually want to do rate limiting or throttling on your API so that they're not overrun. And we'll talk about that. Bot protection. Everyone has bot protection. It's not your reCAPTCHA. This is basically a very crafty way of ensuring that they're not. It's not a bot interacting with your web or API application. And then you got to have intrusion protection. So it's one thing to see that there's a threat against your environment, but it's a whole different story if you know that's really happening now in real time. It's an active threat. It's very dangerous. Why do you want to just look at that threat and monitor it? Why wouldn't you want to prevent that? If you believe and you have a confidence that you have a high degree of efficacy for your threat intelligence, which is AI based, which Checkpoint has, then you will be wanting to block and proactively prevent those attacks. And we need to talk about that a little bit more. I will say, I think our WAF is amazing. It's not hard for me to say. It uses advanced neural networks. So we do classification, supervised training, we do unsupervised learning, and we do risk scoring, and we'll talk about it. But all of these attacks, so the Log4j, Spring4Shell, we found these before we actually knew what they were because they weren't signature based. They weren't known signatures that you could block on. They were heuristic behavioral things that actually were abnormal. And that's what we actually keyed on. And we gave it a high risk score because of the remote execution and the things that we thought were abnormal based on heuristics. Well, we blocked it. The customers that had the blocking, the prevention turned on, blocked on those attacks before we actually knew what those attacks were. All right, how it works, it's basically kind of a two stage. So the first stage, we actually are doing supervised assessing the communications based on supervised learning. So classification. We fed all of this signature data, structure, queries, all these things we know about. There's over 2 million that we fed into the engine. So it knows about all these things. Those things are easy breezy. If everything's good, let the traffic go to the next level. If something's bad, just block it there, right? No problem. If we look at it and we see that there's some type of heuristics that's not normal, we're not sure, we are very suspicious of this traffic, then we're going to actually send that to our engine to do the neural network piece of it, which is deep learning to risk score that. So we're going to look at behavioral analysis and a bunch of other things. We're looking at the client side behavior, the IP where it's coming from, attack indicators, session IDs. Puppy is snoring over here. User behavior, and then we're going to actually kind of look at crowd behavior, trusted users, the application itself, and we're going to come back with the risk score. So if we deem it, we don't know really what it is. It's unknown, kind of unknown. We know it's not normal for this application. These things are suspicious. Then we'll risk score it. Why is it suspicious and highly subject to blocking is because we know now with our unsupervised learning that something is very wrong with this, and with that high risk score we'll block the traffic. We do bot attacks. Basically, we just give a little bit of script back to the client side and invoke user behavior. So we want to see if the user is really there, it's really a human and not an automated application or bots running to actually attack us. Once we get that, we decide based on the user behavior if that actually is a human behind there or it's a bot, and we will act accordingly. If it's not a bot, then the traffic can go. The other thing is we can do API schema enforcement. That means I'm doing validation. So if I'm serving up APIs via endpoints to my customers or applications I'm serving my customers, I'm actually going to use Open API specification. So I'm using RESTful APIs. They meet the Open application Open API specification. Now I'm going to feed that enforcement scheme, even if I have a special scheme. I can feed that up to the WAF engine and say, hey, enforce on this. And anything that's not meeting that specification, either my custom or um, open API specification, then I will block that traffic. So if it's compliant, it will go. If it's not compliant, it will be blocked. And the thing is, that doesn't mean it gets through. There's still the second part of the engine. So if there's something weird about it, initially we can just drop it based on not conforming to schema that we approve. Uh, if there's still something wrong with that communication, the second part of the engine will catch it. I want to say that pretty much every customer I know wants adherence to open API specification, and we have APIs that we serve to customers for threat intelligence, threat preventions, all kinds of APIs for management of the security platforms. And customers want us to maintain open API specification on those as well. All right, a little bit of WAF architecture, if I can speak. So we have this thing. It's called a nano agent. Basically, it's a little software code. It can run. You can run it as a full virtual machine in a virtual machine scale set or auto scale group with EC2 instances or MIGs in Google Cloud Platform. You can run this on-prem in VMware. So it can be just a OVF or OVA template that you can deploy. You can scale these laterally. They're basically in between the load balancers, so it's a piece of cake. You can put it right on an ingress controller. So if you have ingress into your Kubernetes, I like to use GCP because I can actually go in there, use the cloud console and the Helm chart, deploy the whole Kubernetes engine. All it's like abstract away. It blows up everything, including the application for me, and then I can start like deploying our agent and testing like within like about 5 minutes, which is pretty cool. So just know that you don't have to re-architect anything. We can deploy in any of these environments, so you can put it right on. You can have a reverse proxy. You can put it on your Nginx native. You can put it on API gateway like Kong or Apache. And that's great. And then we have like an enterprise class edition where you can actually acquire that engine or that agent rather via our portal. And then you can get management dashboards that are very 3D vector graphic showing threat intelligence and correlated security events, which is pretty cool. It's a good way to show the business in runtime and the team when that application's up in production runtime how it's behaving. The other components you should know, I talked about the agent deployment, super easy using like Helm charts, infrastructure as code. Um, you can use GraphQL API, you can use Terraform Service Provider. Everything's available for you. It's all as code. The agent includes an attachment, which is actually attaching it to Nginx or the reverse proxy or the gateway, the API gateway, an HTTPS transaction handler, an orchestrator, and a watchdog. So on these, they're basically, if you will, functions that are running within this agent, and they all have their own they have their own things that they do. they report their health into with the watchdog into the portal, or you can get the status and health at the command line. So it's all WAF as code. I'm going to show you the Open AppSec IO. You can actually just do it from a cloud console or a Linux console. It's all cloud native. Configuration is code. You can use your custom resource definitions, your Kubernetes YAMLs, JSON config files, annotations. You can manage it locally. You can manage it via the portal. And you can log in your standard output or to syslog, and you can also integrate with Grafana and Prometheus. It is, if you like this and you play with it, the free version, and you want to get the enterprise version, it's easy. It's just a SaaS offering that we have, and we can help you with that. That gives you the web UI and the portal access and reporting and historical information. You can manage the agents from there. Very simple. I'll show you in a minute. Um, all of the event logging is in the cloud, and the portal provides, of course, centralized management for the agents. What else you want to tell you? So again, we have code for everything. So if you like Ansible, if you like Terraform, if you like Puppet, you like Chef, you want to GitHub Action, you want JSON and YAML, all those things we have available for you. All right, so if you want to play with this, we're going to go to the WAF Playground. If you go to https openappsec.io, you'll see the free community version. You can convert it to enterprise version if you want. You do have to create an account to run through the lab. It's only who's using the labs and also protecting those lab environments, so we don't spam you. Nobody's gonna pick on you. You're not gonna be put on some like salesperson list unless you want to. And then you can actually like play with this in the lab, and you can deploy any version that you want on the fly with nothing to worry about. That lab space is on demand. It's on our dime, and it helps you a lot. So if you want to play with this or you need help, there is my LinkedIn again. My name is Micki Boland, Micki. My real name is Michelle, Michele Boland, Boland. All right, so what's out there in the WAF playground? This is if you go to OpenAppSec and you go to the playground, you can see that we have like Kubernetes Kong playground, Linux Nginx, we have Kubernetes Ingress, and you can kind of look and see there's just a little high level kind of architecture, bare bones architecture of what's under the hood there. You can do the Docker Nginx playground, Docker Kong, and Nginx. So Docker Nginx. If you want to do the Kubernetes CrowdSec playground, super fun too. I would recommend. And if you need to do a reverse proxy, is a piece of cake. Just let me know. All the documentation is in the docs. It's free. It's all public. So we don't hide anything from you. You can go there and get it. The code's there on GitHub. And for this lab in the playground, though, it's very efficient and very fun to do the lab. All right. So provided that my little mini video will run appropriately, I'm going to walk you through this lab. So the first thing is you've got an account, you went to openappsec.io, you went to the playground, you logged in. Now you want to pick which lab you want to run. So I'm going to use the Linux Kong playground, and we're basically going to deploy Kong Gateway. First of all, we're going to exploit an API. We're going to do SQL injection against the API. Then we're actually going to install Kong, and we're going to deploy the agent, the WAF agent, and show you that it actually does block the attack, and it gives you intelligence on what happened with that attack. And then we'll actually acquire that agent to the management portal and let you see, instead of looking at logging on, your command line will actually show you logging data in there. So we're just doing a simple thing. We want to attack an API. We're going to grab a token. We're going to create a API token. We're going to grab it. Now we want to run this request to see if we can get employee details for John Smith. And we can see that we can pull, hey, that's a common thing, right? Probably not for, you wouldn't expose this publicly because it's employee data, but for something internal, sure, yeah. But now I'm actually going to do a SQL injection and see if I can get all of the employees' information. And I will do it. I actually do a ultra super secret no ultra easy SQL injection, and then just see if I can do it, and it works. Like honestly, this is a low cost thing for a hacker to try, and they will try it. For APIs, they'll go out there and inventory all the APIs that are exposed. They'll try the most simple thing. So you see there, I was able to inject the API and get all of the employees' information. So now we want to go and deploy a con gateway on Linux. You guys, your APIs should all be hosted or going through a gateway. So if you're not using API gateway as a best practice, please start doing it or consider how you will start doing that. So first, we're just going to install Kong, and then we're going to ensure that traffic is forwarded to port 8000. So we just do that, and then we're actually going to start and restart Kong. And we're going to verify the deployment is successful. And again, communications to Kong. And now you can see we did the SQL injection again. It still worked. We have a Kong gateway, but the SQL injection still works. So now we're going to go and install the actual WAF agent on the Kong gateway running on Linux. So the first thing we're going to do is the install script. These in this lab are copy paste. All you have to do is copy paste. Again, all of this code is done in Helm charts or like JSON. So you can, or YAMLs, you can run this or Terraform service provider. So we actually are just going to install the agent. We're going to turn it to auto prevent when we see attacks. So he's going out there, he's building the agent. It'll take just a minute or two. And then once the agent's up and running, we can use the following commands. So we want to look at the status of it. You can see that it updated the Nginx, the Kong stopped and started, and we installed the Open AppSec agent or WAF agent now, and it's been successful. So we put it on auto protect or prevent, and we can list the policies that are enforced. There's a threat prevention policy. We can look at the logging. So we can look at view logs here. We can start and stop the agent here. So like if you just wanted to play with this in the lab, you can do all this code. You can get this code into one template and run this and have this thing up and running, your Kong included, and then you can just destroy it. It will be essentially the same code. So now we're going to actually, now that the agent's on, we're going to run that SQL injection attack again. And you can see that the agent blocked it. So the WAF agent blocked it. You can see the authorization token. You can see what the policy was, why it prevented it was a SQL injection, where was the traffic coming from. So now you have real telemetry data of a real security event. You can get this again on your console, or better yet, you can actually now attach this agent to the Checkpoint Open AppSec Management portal, and then you can see your telemetry data there. Ultimately, for a lot of these agents running, they're going to be in different places. They might be doing reverse proxy in one application. They may be doing Kubernetes ingress for another application. You're going to want to like manage your agents separately, and you're going to want to see based on where these things are deployed what is actually going on from a security event. The coolest thing that I will tell you is that your runtime threats, like real-time threats against your environment, will immediately show up. You'll see real threats. You'll see real security events that are correlated, that are real-time, they're contextual to you. If we know it's a threat actor, you're going to see that this is the threat actor. This is where they're coming from. And the other cool thing is we actually, when when these agents first deploy, they know they're supervised training. They start doing machine learning and neural networks to actually learn how people are communicating with this application. So it'll start graduating. You'll see that it's doing machine learning, and it'll come back and actually have the human do some guidance for what is actually, what is it thinks is suspicious, maybe normal traffic. You have an opportunity as a human to guide it, but it'll actually self learn and self train, which is quite amazing. He won't block in the advanced learning unless human is involved. So what you saw there is we just created an API key. We use the WAF agent deployment on Kong Linux, so the API gateway is Kong. And now we're actually we ran some attacks. We're going to run a SQL injection attack again. And we're going to actually look at this attack. We can look at it command line, not so pretty, not historical data. You don't want to do a bunch of parsing and all this stuff. So we'll go to the management portal now and we'll look at this in the management portal. So again, there we can check the health of our agents. We can see what's going on from a threat intelligence and AI based threat intelligence perspective. We can see active attacks ongoing. And this is the SQL injection. You can see the SQL injection. It is in prevent mode. What prevented it? It's the action was prevent, based on the policy that's being enforced. It was SQL injection, what was actually done, and where did this traffic come from. So you might be actually doing something internal in dev that looks like a SQL injection. And you can actually go in there and whitelist. Maybe it's coming from this part of the network, or it's coming from this endpoint, or it's actually just dev test and it's completely sandbox. So with that, I think I want to stop this. So I have this running. I don't know if this is still recording because my screen went wonky, but I just wanted to say thank you for being here. It was great to be able to talk to you, and I hope that you find value in this. And I wish you every success today and always, and all blessings. And again, I love to help in any way. There are teams here, not millions, but there are a lot of people. We're helping customers and potential customers every day. We're helping in communities and user groups and at conferences. So please don't hesitate to reach out. And then again, thank you for your time and for being here today.